So, thank you again. My name is Thomas Moschny. I'm working at ParTec in the software development department for 2.5 years now. And this is the agenda of my talk today. I will first give a brief overview over ParTec, what we are and what we are doing. And then we'll talk shortly about motivation for this talk, cluster reliability. I will present the Europa cluster. Most of you might know this, but I will remind you of some details. And then I will highlight some special tools in our cluster suite that especially have been developed during the last 2 years of our engagement on Europa. And if time permits, I will show you piece event, what we call the next generation framework for handling faults on large clusters. Very short ParTec history means we have over 10 years of experience in cluster computing. It all started at University of Karlsruhe in Germany at the group of Professor Tichy at the computer science department, where communication, hardware and software was developed. Later on, ParTec was founded as a spin-off, and we developed software for Maricom cards, especially a communication library and an MPI on top of that, and a management daemon. Over the years, we added more support for different interconnects, and we also added tools for managing and monitoring and deploying large clusters. Currently, we are at version 5 of our ParStation software. Parts of it are open source, and we are currently developing it further. That's what the ParStation cluster suite looks like. We start with a standard Linux distribution, might be SUSE or Red Hat or one of the clones. We add the communication library and our MPI together with process management. We have very good tools for system provisioning. We add tools that we call the health checker and issue tracker, and I will talk about that today. Then we have a grid monitor, which is a monitoring solution that shows the overall state of a cluster in your browser. And of course, we add, as the customer needs, a batch queuing system and a parallel file system. And that all together makes the ParStation cluster suite. So, about cluster reliability. Each of the components you have in your commodity cluster might have a huge mean time between failures. But if you are having a lot of these components, your mean time between failures for the complete cluster drops dramatically. And we are thinking of petascale. So if you have 100 nodes, you might have one failure a week. If you have 10,000 of nodes, you might have a failure each hour, or even worse, because you do not only have hardware components, you have also software components. Most of these failures don't prevent us from running jobs, but of course you might not be able to run a job on the whole cluster, which you want to do sometimes at least. But what the great issue is, that you have to take care of all these failures. If you have one failure an hour, you can't do that with some sticky notes somewhere on your monitor. Yeah, you have to take care of all these failures, so none of these failures gets out of sight. So what are the requirements for cluster reliability? Automized error detection and error correction. Tools providing support in error handling. That's what I'm going to talk about. Powerful analysis tools. I will give some motivation later. Experienced people, like for example ParTec has. You need a scalable and fully tested software setup. You need fault-tolerant software infrastructure and redundancy. We already heard something about that in the morning. So MPI is going to be way more resilient to failures, hopefully. But that's not something we do development on currently. I'm going to talk about the Europa cluster. The Europa cluster is located in Jülich, Germany, at the Forschungszentrum, which is one of the largest interdisciplinary research centers in Europe. It has 4,500 employees. And within the Forschungszentrum, which was originally a nuclear research center, but now is doing physics and all kinds of interdisciplinary research. The JC is located. That is the Jülich Supercomputing Center. It provides supercomputer resources, IT tools, methods, and know-how. And it operates the central supercomputers. One of those is Europa. And Europa is divided into two parts, but those parts are made of almost similar hardware. The so-called JC part is made of 2,000 compute nodes from Sun, Oracle, and the HPCFF part is made of about 1,000 Bull nodes. So we have about 18,000 cores and 207 teraflops peak performance in the JC part, and half of that in the HPCFF part. I showed you the hardware already. Now what about the software? We are running a Linux, standard Linux OS, SUSE Linux, Enterprise Edition. On top of that, the ParaStation version 5 cluster middleware. And of course, Intel development tools, so compilers, libraries. They are using Lustre for I/O, have gateways to GPFS. The batch system is Torquay together with Moab scheduler. And the MPI mostly used is the ParaStation MPI, of course. But if people want, they can use Intel MPI or other MPIs. What's the status today of this machine? It is at 90% aggregate utilization, which is very good. Of course, the utilization outside maintenance slots. Of which we had originally one per week, and now I think one each other week. And the JC portion is currently overbooked 7 to 8 times, which is a good indicator for the popularity of this machine in the scientific community. The machine started at place 10 in the top 500 list and is now on place 23. So what we learned when running this machine is that we need automated tools for finding errors, for early detecting errors. And this is what we call the ParaStation health checker. The overall aim is to ensure that a node is ready to run jobs. And whatever needs to be checked will be checked by the health checker. It is, first of all, a framework. It's robust, extensible. And we already have a list of generic tests. So we can check hardware parameters like available memory. We've seen that several times that the machines come up and don't show all of the expected memory due to BIOS errors or whatever. So this is checked, disk space is checked, the network setup is checked, BIOS versions. It's not at all easy to have 3,000 nodes all on the same BIOS version. All cores must be available, disk health is checked, IB bandwidth, counters and connectivity is checked. Also we check for certain software parameters, so to ensure that the MPI, the management team, and all these tools are on recent versions, on tested versions. Also file system availability, missing services, or there might be processes still running that shouldn't be running. Because it's a framework, it's easily adaptable to new problems, and all tests are sorted into classes, so we can support different hardware or software configurations at once. Also, we support error levels, but that's not widely used because a warning is in many cases not very helpful. So you need to know whether the node can run a job or it can't. So getting a warning might be interesting in case of disks maybe, but in most cases you are simply interested, is the node okay or is it not okay? The health checker is integrated with the batch system, and we have all tests, besides being in classes, they are also in groups, and the groups are for the groups determine when the tests are run. So tests are run at prologue or epilogue time, so before or after job. They can be run at boot time, they can be run manually, and also we have some tests that stress the machine, and they are of course not run automatically but also manually. Typically runtime is 10 to 30 seconds, depending on configuration, but stress tests run longer. We have a set of actions that can happen if tests fail. We can send email, of course, but you get a lot of emails, so that's not a perfect solution. We can set nodes offline, power down them. That's especially important in the InfiniBand case, because if you have problems on the InfiniBand, OpenSM will start logging a lot if there are problems. And we create tickets. I will show you our ticket system in a few minutes. All findings are logged, of course. Two special modules are for InfiniBand checking. We periodically analyze the IB fabric counters, not from the compute nodes, but from admin nodes. And we disable faulty IB links. We take nodes offline, as I said, or create tickets. Also, we are checking the machine check events. That's mainly for memory. So all compute nodes forward their system logs to the admin nodes, and on the admin nodes we regularly check for MCE problems. What ticket system do we use? We decided to use the track system. Some of you might know that. It's in the open source community, it's very popular. It's written in Python, it's easily extendable because it has a capable plugin interface. It combines bug tracker, wiki, and source browser. We don't use the source browser, obviously, but we use wiki features and bug tracking. And we maintain our own set of plugins to especially suit the ticket system for our needs in this cluster environment. Here you can see the first page of the Europa track system. So you can easily, as it is a wiki, you can easily embed graphics about utilization, for example. What we also learned is that integrating a ticket system with certain vendors isn't actually easy. So we decided to use email as the basic communication medium, and to establish standard procedures. So our track system can send emails to the vendor about new tickets, and the vendor can answer to these emails. And all this is done automatically. So the answers are automatically attached to the tickets. And of course, the vendor has its own tracking system. It might be a good idea later to come up with some solution that directly interfaces with their ticket system, but vendors are hesitant to do that. We have a plugin especially for this use case. It is for exporting ticket data with all the history. As I said, track can be very easily extended, and so this is one of the plugins we wrote. PS Track Tools is another extension. As I said earlier, the health checker has to create new tickets if something goes wrong. And we don't want to have some web interface for that. So the health checker can use a set of command line tools that accesses the track instance via XML RPC. And it also bridges the gap between these different databases. The ticket system is sort of a database for the node status, and we have all other databases like the batch system, which also has a notion of up and down nodes, and our ParaStation management team, which also has a notion of up and down nodes. And to sync all these databases, we use this set of tools. It easily shows differences in the databases, and it can be used to sync between these databases. Then I was talking about statistics. We learned that we need statistics to get a fast and objective overview of the state of the system, to be able to argue in front of customers and vendors. In a big system, a lot of money is involved, and so you have to be prepared. You have to be able to tell what's going on. You have to enforce fulfillment of contracts. You have to optimize spare part ordering. You have to control and evaluate your maintenance activities. And of course, you want to learn something for the future, for future procurement measures. And our statistical data can help doing that and reducing time and cost. At the very beginning, we used Excel sheets, exported ticket data somehow, and run Excel sheets on top of that. But finally, we came up with our own plugin doing that. With the plugin, you can get ticket statistics on the fly. It shows open tickets, open close rates, ticket residence time, which is especially important, reaction time. This all gives you good arguments if you are in a dispute with the vendor or the customer. So I will skip a bit of the text and show you the screenshots. This is what it looks like. You have here the components. All tickets are grouped into components, so like hardware components and software components. And you can drag and drop them here, and your statistics will immediately get updated. You can select time ranges and different types of statistics, as I said, like ticket open, close rate, residence time, and the like. Of course, if you are the Excel sheet hacker, then you can download all the data and you can bookmark the settings for later reuse. Okay. The lessons learned on Europa, it enables defending finger pointing by using objective data instead. So people have some idea of what's going wrong, and you can say, wait a moment, I've got my statistics here, and you are wrong, maybe. We can give aid to the customer, so the customer has a better standing against the vendor. And in the case of Europa, we have this special situation that there are two similar-sized, almost identical systems, and we can compare stability and reliability and reaction times. So, for example, if you look carefully at the statistics, you can even see those changes, like from Sun to Oracle, and you see a small hiccup in the ticket data. The health checker may produce a lot of tickets, but that's not a problem. That's good. You learn about hardware problems early, and you have to know them. At the beginning, we had a lot of hardware problems, especially disk and memory. Currently, we have a closure rate that is almost identical to the opening rate, but at a very low level. So we have about 200 tickets or so currently open. There's a small drag of tickets. Some of them have to be taken care of, especially in longer scheduled maintenance slots. So overall, we can say we reached an efficient workflow. Procedures are well known to all parties, and the system is running very well. So I think time has run out. I will skip this a bit and say thank you, and if there are questions, I happily answer them. We have our COO here today. He will also be happy to answer your questions.